Hi everyone, welcome to Numeric Learning. In today's video, let us solve NCERT exercise 2.1 of the chapter Polynomials. Let us read the question clearly and try to understand as to what you need to know in order to solve this kind of questions. The question is, the graph of y equal to p of x are given here. Okay, so the graphs of y equal to p of x is given below. For some polynomials p of x. So what is p of x? P of x is a polynomial. Find the number of zeros of p of x. Now before we solve this, let me tell you a brief about what you need to know, right? So here y is equal to p of x is given. What do you mean by p of x? P of x is a polynomial with variable x. Okay, now there are different kinds of polynomial. Based on the degree, you have multiple types of polynomials. One type of polynomial is called the linear polynomial. Linear polynomial. Okay, now linear polynomial, just an example, you can write it as y is equal to ax plus b. This is a linear polynomial. So what do you mean by a linear polynomial? A polynomial wherein the highest power of the variable is 1. So what is the power of x here? X is 1. So the degree of the polynomial is 1. If the degree is 1, it is called a linear polynomial. Always remember. Okay. If the degree is 2, for example, if I am writing y equal to ax square plus bx plus c. Okay. So here what is the highest power of the variable? Variable is x. Okay, so a, b and c are all constants or coefficients. C is a constant, a and b are coefficients. So what is the highest degree or highest power of the x, highest power of the variable x? That is 2. So if it is 2, then that means you can say that the degree is 2. And if the degree of a polynomial is 2, you call that polynomial as a quadratic polynomial. Okay, and if the highest power of the variable in a polynomial is 3, right? So it is say x square plus c. If the highest power of the variable is 3, then you can say the degree of this polynomial is 3. Hence, therefore, it is a cubic polynomial. Okay. And how do you find? So if you are given a polynomial and if you are asked to identify what is the degree, just make sure you understand what is the power, what is the highest power of the variable. Whatever is the highest power of the variable, that is the degree. And if the degree is 1, it's a linear polynomial. If the degree is 2, it's a quadratic polynomial. And if the degree is 3, it's a cubic polynomial. Now another thing that you have to know is, if it is a linear polynomial that is of degree 1, okay, the maximum number of values of the variable that can give you the polynomial value as 0, that is only 1, maximum 1. Let me explain it here. Suppose you have p of x is nothing but x minus 3. Okay, so what is the degree of this polynomial? Degree of the polynomial is 1, because the highest power of x is 1, and if highest power of x is 1, the degree is 1, and if degree is 1, it's a linear polynomial. Now, what is that value of x, which when substituted will give the value of the polynomial as 0? So if you equate this to 0, right, x minus 3 equal to 0, then x equal to 3. Now, if you substitute x as 3, 3 minus 3, it is 0. Okay, so 3 minus 3. So, what is that variable value which when substituted will give you a 0? It is x equal to 3. Now, this 3 is called the 0 of the polynomial. It is called the 0 of the polynomial. Okay. Now, is there any other value of x which when substituted here in place of x will give you a 0? No, it is not possible. It is only 3 when substituted will give you a 0. P of x as 0. So 3 is the only 0 of this polynomial. Okay. Now, because the degree is 1, Okay, always remember, if the degree of a polynomial is 1, the maximum zeros of the polynomial will be 1. That means there will only be one zero. If the degree of the polynomial is 2, the maximum number of zeros of this polynomial will be 2. Maximum 2, it can be less than 2 also. And if the degree of the polynomial is 3, then the maximum number of zeros of this polynomial will be 3. Maximum, or you can also say at most. It cannot be greater than 3. Okay, so how would you say, when you have a polynomial, how many maximum zeros it can contain? You can say that with respect to the degree of the polynomial. And how will you know the degree? When you correctly calculate the highest power of the variable. So degree is nothing but highest power of the variable will give you the degree. And with degree you can definitely say if it is a linear or quadratic or cubic or biquadratic polynomial, and how many maximum zeros it can contain. Okay, so this is what is the prerequisite in order to do this question. Now in this question, always remember, you have to find the number of zeros. What do you mean by number of zeros of p of x? That means the number of values of x that can make p of x 0. Okay, so whenever you see this graph here, right, these all the graphs are nothing but they are the graphs of the polynomial. They are polynomials that are given in the graphical form. Okay, and in order to find the number of zeros of p of x, you have to see in how many points does the line or a graph cut the x-axis. So if you see in the first question, it does not cut the x-axis at any point, right? It does not cut. So here the number of 0 is going to be 0. In the second one, see, look at the graph here, right? This is your polynomial graph. The number of points at which it cuts your x-axis is only 1. That means the number of zeros is going to be 1. In the third one, the graph cuts the x-axis at 1, 2 and 3. So the number of zeros here will be 3. Here in the fourth graph, it cuts x-axis, the polynomial graph cuts the x-axis at 2 places. In the fifth one, it's 1, 2, 3, 4. So the number of zeros of this polynomial will be 4. And here you can even if it touches the x-axis, that is also a 0. So 1, 2 and 3. So here the number of zeros of p of x will be 3. So it's very, very easy to calculate. Okay, always remember the number of points that it cuts or touches the x-axis, the graph. Okay, that many zeros it will contain. Okay, so hope you understood. This was exercise 1. This was exercise 2.1. Hope you liked it. Please do share it with your friends and do subscribe, and please do comment if you understood this very well. See you all in the next video. Thank you.